This is Kaylee and Andrea's podcast on how to find the distance between parallel lines, which is a concept found in lesson 3.6. So along the way, we'll be doing a practice problem, and the problem reads, find the distance between the parallel lines L and M, whose equations are y equals negative 3x minus 5 and y equals negative 3x plus 6 respectively. Step 1 is to find the equation of line P, which I've done in right here. And keep in mind that P's slope is the negative reciprocal of L and M slope because line P is perpendicular to lines L and M, and we're going to use M's y-intercept as one of P's points. So P's slope will be the negative reciprocal of negative 3, or 1/3, and one of P's points will be 0, 6, or M's y-intercept. So I've written that down here. And we're going to plug these values into the point slope formula, which is y minus y1 equals m times x minus x1. And you find that line P's equation is y equals 1/3 x plus 6. Step 2 is to set lines L and P equal to each other. And this will find the x-coordinate of the intersection of lines L and P. So the equation will be negative 3x minus 5 equals 1/3 x plus 6. And x will equal negative 3.3. And then you plug this x-coordinate into the equation for either lines L or P to find the y-coordinate of the intersection. And so I've chosen to plug it into line L's equation, which is y equals negative 3x minus 5. And I plugged negative 3.3 into x and found that y equals 4.9. Finally, step 3 is to find the distance between lines L and M. And we're going to use the intersection between line L and P as 1 point in the distance formula, which we found here in step 2. And we're going to use line M's at y-intercept as the other point, which we found here in step 1. So I plug this into the distance formula, which is d equals square root of x2 minus x1 squared plus y2 minus y1 squared. And I found the distance between lines L and M equals the square root of 12.1, which is approximately equal to 3.48 units.